Hello and welcome, guys! I'm so glad to be back with this new course about making a multiplayer game using Unity's new netcode for game object system. Perfect! So, this course supposes that you already have some basic C# knowledge along with some basic Unity knowledge. If that's not the case, please go watch my video on YouTube. So it's a video about Unity's editor, and you'll learn a lot of stuff related to Windows and basic elements. And I think that's it. So let's jump right into making the game. All right, so I have Unity Hub opened right here. So I'm going to create a new project. I'm going to use the 2022.2.1 F1 version. So you can use a later on. I think it's going to work as well. Perfect. Let's select 2D template because the game is going to be 2D. And let's rename it Mushy Bounce. Maybe course. Yeah, Mushy Bounce course. That's just for me. All right, perfect. Let's let Unity create the project for us. And during that time, you can take a nap. All right, Unity has set up the project for us. Perfect. Let's now start making the game. All right, so the first thing you might want to do is to switch the platform to Android. And for now, it's better not to. Why? Because we are going to do a lot of testing for multiplayer, okay? So it's better to keep Windows, Mac, Linux as the target platform for now. All right. So the first thing I want to do is import some assets that I've made especially for this course. So I'm not a great artist, but come on, it's reasonable. Okay, here they are. So I'm going to double click it and import them. Perfect. I'm just going to drag my scenes folder and drop it onto the Mushy Bounce folder so that I have everything under one folder. Nice. I'm going to have a look at the sprites. So we have a basic background, a bush, a button template, an egg, which is going to be the ball, some mountains, a mushroom. I think we won't be using this one, but it's there in case you want to. The mushroom head, the mushroom stick, and some mushroom dots. All right. So the first thing I want to do is drag the mushroom head and drop it onto the hierarchy. Okay, so this is going to be our player. So I can already maybe rename it player renderer, like so. Nice. I think I'm going to right click it and select create empty parent. Why? Because if you have taken my previous courses, you know that I like to separate the logic of a game object from its graphics and its rendering. Okay, that's so much better because we won't have issues when dealing with scaling and so on. You can animate your renderer without touching at the logic of the game or the scaling of the main game object. Okay, so yeah, keep that in mind. And of course, experiment. Do a lot of experimentations. All right, so this is going to be the player. Perfect. Next, we want to change the color of the player to maybe something bluish. All right, perfect. I'm also going to set up the camera. So the camera is currently in orthographic projection. That's exactly what we want because we are making a 2D game. But I want to make it a bit bigger. So I'm going to set a size of 10. Okay. And maybe move it a bit higher. So maybe 2 or 3, something like that. Because the ball is going to be bouncing in this zone. So I think the larger it is, the better. So maybe 4. We still need to take into account the zone where the player will move the thumb. Okay, so yeah, I think let's keep it 3 for now, and we can tweak it later on. Perfect. In this first lesson, we are going to create the player controller to move the player around. Okay, so I'm going to open the project window, right-click, create a new folder that will hold all of my scripts. Perfect. Now I can create the new C# script, which is going to be the player controller. Awesome. I'm going to drag the script and drop it onto my player. Now the script is attached to the player, so it can be used. Perfect. Let's open it. Okay, let me quickly explain the logic of the control. So I want the player to touch the screen and drag on the screen X and on the X-axis to move the player along the X-axis too. Okay, so maybe we will have a minimum of -4, something like that, 4.5, and maximum force and a maximum value of 4.5 along the x-axis. Okay, so we can already imagine that we are going to need some clamping to clamp the position of the player. And we are going to make use of the input class to get the position where the player clicked on the screen. All right, let's jump right into it. So in the update method, I'm going to make a new method. So let's call it manage control. So it will be called 60 times per second on each frame. It's going to be a private method, manage control. All right, perfect. Then we want a condition here. So if the player touches the screen, okay, what are we going to do? We are going to save the X position of that screen click. So let's say clicked screen position, or maybe clicked screen X equals input.mousePosition.x. So I'm not using the touch class again, just to make things a bit simpler. And you can always complexify the code and adapt it to your own needs. Okay. So we need to create a variable for that clicked screen X. So let's make it here. I'm creating a header. So for those of you who don't know what a header is, it's basically a way to organize your elements in the inspector. Okay. So let's call it control settings, maybe private float clicked screen X. Okay, so now I've created my variable, so it's a float value. After that, I can check else if. So if the player is dragging his finger on the screen, so get mouse button 0, like so, we can calculate the difference between the current mouse position or the finger position, finger X, and the clicked screen X. So let's call it float, maybe X difference will be equals to the input.mousePosition.x minus the X position the player clicked at. Nice. We can already debug that to check if that works properly. So debug.log X difference equals like so. Okay, I'm going to go back to Unity now to check if everything is working properly. All right, so I'm clicking, X difference equals 0. I'm moving to the right, 300, to the left, minus 400. Perfect. Working exactly as expected. Nice. All right, let's go back to the code now. So just to make the game a bit more responsive, I want to divide this X difference by the screen width. Okay, because every device has its own width in terms of pixels, and you want your game to be responsive. So you need to divide it by the width of the screen. And same thing if you're using a vertical control, you want to divide by the screen height, okay, or multiply. It's as you wish, but you need to take that into consideration. Okay, perfect. After that, to have more freedom when tweaking the value, I want to multiply this X difference by a certain move speed. Okay, so let's create this float value, which is going to be the move speed. Okay, private float move speed. But I want to be able to change the value from the Unity editor, not to jump to the script every time. So I can either make it public, which is really not recommended for object-oriented programming, or I can use the serialize field attribute, which will allow us to tweak the value from the inspector, even though it's private. Nice. So I'm going to go back to Unity. Okay, perfect. Let's make it, let's say no, I think I'm going to make it like 1 for now. Hit play. Okay, so now if I move, I can see that the X difference is much lower than previously. Nice, but I think it should be a bit higher. So let's make it 8 for now. Okay. Nice. 4, minus 4. Okay, minus 2, sorry. Okay, it's kind of good. And we can still increase it and play with it a bit, okay? Do your own experimentations regarding this. Okay, so I'm going to leave it to 10 because 10 seems to be a good value. I can go from minus 5 to 5 just by dragging my finger from right to left here, and that will be convenient for the player. Now, what's left, I think, is to move the player. So what we can do is write transform.position equals new vector 3, X difference for the X-axis, transform.position.y for the y-axis, and 0 or transform.position.z for the z-axis. Okay, and you can actually use a vector 2. It's going to be more convenient because we are in 2D. Okay, we are making a 2D game. I think we can hit play and have a look at it because we are going to change something, but you will see what. Okay, so now when dragging my finger, it does move. But if I start from here, you see that the player has jumped to the center of the screen, and that's not what we want. We want it to move from its old position, okay? So we need to store that position. We need to store the X position of the player when the player clicks on the screen, okay? So what we can do is create a new variable to store that value. So I'm just going to hit Control D to duplicate this line. It's much more convenient to create a new variable like that. Clicked, let's say player X. Okay, cool. I'm going to initialize it here. Whenever the player clicks on the screen, equals transform.position.x. Perfect. And now I need to take that clicked player X into consideration. So I can say that float new X value or new X position equals clicked player X plus X difference. Did you got it? If you don't got it, please leave a comment. I'm here to help. And instead of applying this X difference to the X value of the player, we are going to apply this new X position. Nice. Let's go back to Unity and give it a try. I'm going to hit play. Okay, now it seems pretty good. So I'm going to start dragging from here. I clicked. Nice. The player has started moving from its old position now. Got it? See how it works? Again, if you have any question, please leave a comment. I'm really here to help. So I've already done that in the previous course. So I'm kind of rushing a bit into it, but it's okay to ask questions. Okay, perfect. So the next thing we want to do here is clamp the position of the player on the x-axis, because for the moment it can go till -infinite and up to +infinity. Okay, so -infinity, you see -50, -72, and that's definitely not what we want. So what we can do is create a new variable. Let's drop it here. So Control D again, or Command D for Mac users. Let's call it max x. And before applying the new x position to the player or to the transform.position value, we are going to clamp it. So new x position equals mathf. So we are using the mathf library dot clamp. So the clamp method takes 3 arguments. The first one is the value you want to clamp. So in our case, we want to clamp the new x position. And we want to clamp it between -maximum x and maximum x. Okay, so let's say we set a maximum x value of 5. The new x position will be clamped between -5 and +5. Okay, so now it should be all right. Let's go back to Unity. I'm going to clear the console and set the maximum x value to 4. Hit play, and it's perfect. The player can now no longer go outside of the bounds that we've declared. So it's -4 and 4. That's awesome, guys. So in the next lesson, let's see how we can create the ball that the player is going to play with. See you there.